So to take a look at completely graphing these rational functions, where the degree on the top and the bottom is the same, let's go back and look at our first example again. That was f of x equal to x over x minus 2. And the end behavior for that, if you remember, well, because the degree on the top and the bottom is the same, the leading coefficients are 1. So you know that the horizontal asymptote is y equals 1 over 1. We also have a vertical asymptote of x equal to 2, because you can't divide by 0. And now we have some x-intercepts, which are the values of x that make y 0. So if x is 0 here, well, then we have an x-intercept. So the zeros are x equals 0. And that's what we have so far. So to graph this, let's put in all that information. Okay, so x, y-axis. The vertical asymptote at x equal to 2. Okay, x equal to 2. Horizontal at y equal to 1. So y equals 1. And then now we got to figure out what's going on with the rest of this. So if we take values that are just to the right of this horizontal asymptote, well, we can see what's going on. But first let's plot the 0 as well. So there's the x-intercept right there. We know the function goes through here. Okay. So now let's look to the right. The function cannot go through the x-axis. So it's pretty much guaranteed that it's not down here, because it would have to come up and approach this as x gets really large. And in order to approach this, well, it must go through the x-axis. And we don't have any more zeros to this. So that's impossible, which leaves us to this by process of elimination. Okay? You try any other option, and it will have to go through the x-axis. Now for this side, we have a similar thing. And so it's on between 0 and 2. Well, we look at this. Between 0 and 2, well, the bottom is negative, and the top is positive. So we've got negative in here. It must go through like this. And then we've got the function coming through, because it's got to come through, and it's going to head towards the asymptote like that. And that's really our only option for that. Let's just change this up just a little bit and do another example where f of x equals x squared over x minus 2 squared. Okay, so again, it's in factored form. We have a horizontal asymptote of y equals 1. Okay, because the leading coefficient in both are 1. And we have a vertical asymptote of x equal to 2 again. And we also have a 0 of x equal to 0. Okay, so mostly the same information as the example above here, except for the top and bottom is squared. So let's see what happens there. And you can kind of guess what happens when you square these positive numbers here. It's going to change that shape a little bit, but it's going to be about the same. When you square these positive numbers, it's going to be about the same. But when you square these negative numbers here, they're going to become positive. So it should flip up like this. And let's see. Okay, so let's take a look and make sure this is what happens. So draw it. We got the x-axis, y-axis, horizontal asymptote of y equals 1, vertical asymptote x equals 2. Okay, so when the x is greater than 2, we have the same situation, cannot go through the x-axis because our 0 is over here. And so we have this piece up here. Now over here, it's going to touch here, but this function is going to be always positive. Something squared is positive, something squared is positive, So it has to hit there, but it has to go up to this asymptote. So it must be coming like this, and then touch. And then it's going to go back up, but then it has to go along this asymptote. It could possibly go through the asymptote and come back down. This function doesn't. But here is proof that the function can go through a horizontal asymptote. Okay, so this is one case where it can. You can always go through a horizontal asymptote, but you can never go through a vertical asymptote. Okay, so that would be the function for there. Now let's take it one step further and take a look at what this would look like if it was cubed. So f of x equals x cubed over x minus 2 cubed. And all same information, horizontal asymptote, y equals 1, vertical asymptote, x equals 2, and the 0 is x equal to 0. And when we graph this, information, x equals 2, y equals 1 of the asymptotes, and same thing's going to happen over here. Can't go through here, so we're going to have this. We've got this point here, and now what happens is the numbers between 0 and 2, well, they're positive on the top when you cube them, but this is going to be negative on the bottom because you're going to get negative numbers. Negative numbers cubed are negative. So it's going to come here again, but it's going to go through here with a cubic twist. So it's going to come like this. It's going to kind of twist up and then twist back towards here again. So this part here, you're going to have a twist. And that would be that function. So that's how that would change progressively as you got a linear over linear, same thing, squared, and then cubed. Okay? And how about we look at something a little bit more difficult, just to get you prepared for this stuff. So f of x equal to 2x minus 2 squared times x plus 1 all over x minus 4 x plus 3 times x plus 5. When we look at this, we see that the top is going to be a cubic. A quadratic times a linear is a cubic. And then 3 terms of a cubic here, that's going to be a cubic on the bottom. So the horizontal asymptote is the leading coefficient dividing by the leading coefficient. Here the leading coefficient is 2, and here is going to be 1. So the horizontal asymptote here is y equals 2 over 1, which is just 2. Vertical asymptote, well, that's going to be x equal to 4, x equal to negative 3, and x equal to negative 5. So those are the 3 equations of those lines. And then the zeros are, well, x equals 2 and x equals negative 1. The values that make the top 0 are the values that make the function 0. Okay, it doesn't matter what the bottom is as long as the top is 0. Well, you can't have 0 on the bottom either, but then you would have factored it out or canceled it out. So now you have the zeros are x equals 2 and negative 1. Okay, and you can see that I've listed the zeros, not x equals 2, x equals negative 1, and so on, because it is a list of numbers. Whereas the vertical asymptote is a list of equations of lines. This is not a list of numbers here. So x equals 4 is an equation of a line. X equals negative 3, equation of a line, and so on. So you need to list asymptotes as equations of lines with the x in each one. The zeros, you can put an x equals for each one, but it is just a list of numbers. Okay, so let's try and graph this. Well, make it a little bit bigger here than the other ones. Okay, so go over here. We've got at negative 5, we're going to have a vertical asymptote. So x equals negative 5. And at negative 3, we're going to have a vertical asymptote. And then at 4, we'll have a vertical asymptote. Okay, label the axes. And then we're going to have a horizontal asymptote at y equal to 2. So across here, y equal to 2. And then our zeros are at 2, right here, and at -1. Okay. Now one of the zeros is squared. So we might suspect that it might just touch there, and the other one is not, so it's probably going to go through. Okay, so let's look at some what's going on here. Well, this is a cubic over a cubic, horizontal asymptote. Why don't we take a look at the signs of some numbers here? This function cannot be down here again, only because it would have to go through the x-axis, and we don't have any more zeros. Okay, so if we had a zero of, say, 6, then it would be down here. But we don't have any, so it has to be up here. Okay, same with over on this side. It cannot be down here because it would have to go through the x-axis, so it has to be up here. Okay. And we can take a look at some values on this side here. So why don't we take a look at f of 3. See what happens here. So f of 3, and we just have to look at the sign. Is it above or below the x-axis? So f of 3, when we look at this, well, top is going to be positive, okay? And the bottom, when I plug in 3 minus 4 is negative, positive, positive. So it's going to be negative on the bottom. And a positive divided by a negative is equal to a negative. Okay, so at f of 3, it's going to be down here. So it's going to have to come like this to that 0. Let's try f of 1, see what happens. I'm guessing that it will also be negative. Okay, so f of 1, well, the top is going to be positive because squared makes it positive, positive. 1 minus -4, that's negative. And then these are positive. So positive divided by a negative. Okay. And that's a negative, so yes, it comes down again. But then it has to go back up and hit this. So it's going to come down, just touch, and then it's going to go back up and go up there. Okay? And again, we've gone through a horizontal asymptote, but we're not going through the vertical ones. Now all that's left is to figure out what's in here. So we're going to try a value in between here, between -3 and -5. Let's try f of -4. Okay, so f of -4, well, this is going to be positive always, this part here, but that's going to be negative. Okay, so the top of this one is going to be negative. And then the bottom, well, when I put in -4 down, -4 down here, that's going to be negative, that'll be negative, and that'll be positive. So negative times a negative on the bottom is positive, times a positive is a positive. So we end up with that, and that equals a negative. So at -4, it's underneath, so it must be like this, because it cannot go back up through the x-axis again. We don't have any more zeros. And that would be the graph of that function. Okay.